collet maintenance is the #1 cause of bad surface finish on not only rolling machines, but all the machines that we're using in this industry. In this video, we're going to go over the working principle behind what a collet is, what it's doing in the machine, and then we're going to go over Dention's procedure on how to do a maintenance on a rolling machine. This will be applicable to all the dry mills. The concept is the same, so this is all the way from DWX 50, DWX 4, 51D, 52D series, and the 53DC series. Principles and concepts are all the same. We use the vPanel software to drive the machine, and we're going to do a physical maintenance on the collet itself. So we've got it down into chapters below if you want to skip forward to just doing the procedure. But we're first going to go over what is a collet, how does it work, and why it's important. So the best place to start in this video is go over what is a collet and what job is it doing. So this is a collet, and this guy is inside of your spindle. You can see it if you look at the bottom of your spindle when it's in the machine. So what is this thing doing? It's physically holding your burr or tool inside of the spindle, and it spins along with the tool. It actually is the thing that grips the tool. And when your machine does a tool change, the collet opens and closes. Here, come in tight on the cross section here we have. So for your guys' convenience, I've gone ahead and cut a spindle shaft in half so we can see the working principle behind how a collet moves. Let's see if I can fiddle around with this and get it stuck on here. Okay, so inside of your spindle, there's a drawbar that is pre-tensioned with these springs. And in the held closed position, the drawbar is all the way up in the shaft. And you can see this tapered area. As you pull this way, the taper wants to close and it applies pressure on the tool. And then as the top of the spindle is depressed to open it, the collet will open and it can put it back. So here, let's watch it close with no tool in it. So I'll slide it down and you can see it closing and opening, closing and opening. So this is good to have an understanding of how this thing works, because when we get into maintenance, you'll have that working principle in your head and understand the importance behind the maintenance. So there's a couple little notes here that I want to hit. The 52D series, or the 52 series of machines, they're delivered with two different spindles. And the spindles are, they use different collets. So if you have an older 52D, it's going to have this spindle. This is the ZS4D. And this is it's also the same spindle in the 51 and in the DWX4, same part. You can tell because you've got two little holes right here. Now, if you have a newer machine, most of them are indicated newer as being a plus model, but there are some models in the middle that say 52D, but they have the plus spindle. So the best way to do it is to visually identify the spindle. And this is a plus spindle. And you can see the difference here on the spindle nose. It has a bunch of little holes in it that are actually for balancing. But you can tell a plus spindle that way. And then also the new version of the machine, the 53 series. So we've got the 53DC and the 53D. Those use the same spindle together. It's similar to the plus, except it's a much longer big boy spindle. Those collets are also machine specific. So to recap, you want to make sure you're getting the right collet for the machine you have. This is going to be old style, new style. Just make sure you're asking your dealer or your parts guy and telling them which one you got so that you get your correct collet. So why do the collets get dirty in the first place? And when you think about it, it's pretty simple. So that collet opens and closes to grab the tool, right? Every time your machine changes a tool, it's going to ingest whatever debris was on that tool when it grabbed it. And it'll slowly over time get impacted and built up on the collet. And so that's why the correct procedure is to fully remove it, clean it, re-lubricate it, and put it back. The next question that we always get is, how often do we do that? And since the working concept behind how they get dirty is tool changes, we suggest that you service the collet by fully removing it and cleaning it every 300-ish units. And then that's going to basically hold your tool change count within a reasonable threshold. And that might be a week for some labs, it might be a month for some labs. So it really doesn't make sense to give you like, hey, do it every week. You want to do it by unit count. When do we replace a collet? Usually we're going to recommend that you replace a collet if you're getting bad results and the spindle's still fresh and you've done all the maintenance, or if the collet is physically worn or damaged. If somebody chucked it on the floor, you might want to just replace it because they're kind of fragile. And then you can also see where you can visually inspect these. Let's see, do I have one that's got some wear on it? Yeah, this is probably a good example. So if you look at a collet really close up and you pay real close attention to this tapered surface, during the life cycle, it's going to start to create wear lines, like witness lines on this surface, because it's sliding and it usually has a bit of zirconia, which is abrasive on this, so it'll slowly get deformed and worn. And so if you hold it up to the light, you can see a wear facet to start forming on that. If it's a gigantic wear facet, or you got thousands of hours on it, time to replace. If we come in on this one, so you can see these are kind of side by side. This is like worst case scenario here. It's nasty. It's worn all that shiny material off the tapered surface. So this one would definitely be a bad one, especially if it's cut in half. It's not going to work. So yeah, that's what we're looking at. It's a visual thing. We were talking to a customer just earlier today about a collet. They're having issues with tool change, and they reported that even with the collet in the open position, the tool was still kind of grabby, like it wasn't smooth. And so what we did is we told them, look, take a look down here, and this ID should be a round shape. It should be circular. If the collet is bent, it'll be more of an oval shape. And if you look at it real closely, you can kind of eyeball that and get an understanding. If you got one that's got an oval hole, it's damaged. You're going to have to replace it. If it's sticky on the tool should slide nice and smooth. It's also damaged. You're going to need to replace it. All right, so now let's jump into how to do it. All right, so to go into your collet maintenance, we're going to need a couple of things. We're going to need our collet grease, some Q-tips, which I prefer the ones with the point, but it's not completely necessary. Then you're going to need a lint-free cloth. And then in addition to that, we're going to need some isopropyl alcohol and optional access to a steamer. Most labs have steamers. We're going to do it without the steamer today. So let's jump into it. We're going to go into vPanel, and we're going to use our maintenance function to send the machine to its maintenance position for the collet. And the way that we do that is we're on the active machine. We're going to come over here to maintenance, and then we're going to go to open collet, which is right there. Read the prompts, pay attention to the prompts, and the machine will now move to a position where it's convenient for us to access that collet. Okay, now we're in position. and we're going to remove the collet fully. Now, there's two styles of tools that come with machines. This is the old one. This is the one that you should be throwing away if you have it. Why? Because you can put it on the collet and apply torque to the collet and bend the collet. It is not dummy proof. You have to have two hands, and this is even difficult for me to do it right here. The way this thing works is you have to have a pin inside of it to support the collet so that it can be, torque can be applied to it. I've never liked this wrench, and Roland recently re-engineered it, and we now have this collet wrench that now ships with new machines. All new machines ship with this, and it's got a pin integrated into it. So one, it can be done one-handed, and two, you don't have any risk of over-torquing or bending the collet if you don't support the middle. If you got one of these, chug it, buy one of these. And by the way, it's just this part. Works with the wrench that came with your machine, like that. Okay, so we're in position. We're gonna open it up, and the collet is in its open position. And the way you know it's in its open position is because it's kind of pushed down. And if you really wanted to, you can freely move a tool in and out of there. If it was closed, you would not be able to do that. So we're just going to come up here with our screwdriver and a lefty-loosey. And once you've got it cracked, you can just come over here and you can run it out by hand. And we're taking this thing all the way out. There you go. You've extracted the collet. All right. Now we're going to come out of the machine and we're going to clean it. All right, let's talk about critical surfaces here. So if the job of the collet is to center the tool to the spindle, then that means that this tapered surface right here is a critical surface, and the ID is a critical surface, the inner diameter, the surface of the collet that actually touches the tool. So we want this thing to be surgically clean, no fingerprints, as clean as humanly possible. An easy way to do that in the lab is to go over there and just lean hard into it with a steamer. Just don't launch it across the room. If you drop it, you probably bent it and it's no good now. The way we're going to do it here is we're going to inundate it with some isopropyl alcohol. We've got it in a spray bottle, and we're going to be able to just go in here and just hit it high pressure, run alcohol through it, liberal, and you kind of have to enjoy the smell of isopropyl for this one. But what you can see is I'm just irrigating every little place where anything could be going. I'm going multiple directions, and I'm not afraid to waste alcohol. All right, and I'm getting it on my fingers, which is always fun. Gloves are recommended if you don't like your skin dried out. Okay, so now I'm going to look at this thing, and there is no detectable grease or debris on the inside. You come in, I don't know if you can get in close to sight down the inside, probably not. But we're clean. Used a clean rag. Ready to go. This is ready to go back, almost ready to go back in the machine. Now we're going to put our attention back on the machine. So I'll ask you guys this. If I've got this thing surgically clean, but this thing is still dirty, does it make any sense that this is clean? It's not going to buy you anything. So we have to go in and clean the tip of the spindle. And actually this shaft here, if you get in close, look at all the garbage that's in there. So that's what you end up with. And that's going to cause your collet to run out of center too. So the kind of the easiest way to attack that is with your lint-free cloth and a cotton swab. Now, we're not going to put this cotton swab directly into the spindle because it'll deposit cotton fibers, which we're trying to get things out of the spindle, not put things in. So we'll take our lint-free cloth, drop it. That's in the official manual, by the way, to drop it. And I'm just going to use the cotton swab to give it some shape. And we're going to inundate this with alcohol. We're going to come back up in here. And I'm just going to feed this up into the spindle, circular motion, and we're going to take it out. And now you can see we got some debris. So the method here is that we're just going to move to a clean spot, put a little more alcohol if we need it, and we're going to keep doing this until it comes out clean. Now, you're not trying to get this all the way up in the spindle. We're basically just focused on that taper because it's a critical surface. Rinse and repeat till it comes out clean. Once it's come out clean, then we know that we're good and we're ready to start thinking about putting it back in. All right, now we're one step away from putting this thing back in the mill. That step's an important step. So these precision surfaces are sliding on each other, so they do need a little bit of lubrication. The number one mistake people make here is right here. So, important. What they'll do is they'll just grab a big old fat dollop and they'll stick it on the collet and slam it back up in there. Please do not do that. What happens when you put too much grease on is that the grease will slide through this little crack and it'll get on the inside where the collet touches the tool, which lubricates the collet's interface with the tool and causes it to not be able to hold on to it. And then you launch tools out of the spindle while it's milling. And that can be real fun. So when we're talking about lube for the collet, we're going to use our Roland grease. It's actually special grease. Don't get anything at AutoZone and just think it's grease. This is meant for this. And if you look at my finger, which is nice and dry from the alcohol, I don't have any grease on it. It's just a little film. And so all we're trying to do is put like a fingerprint film. That's it. Imperceivable. Just so that you could, hold it up to the light and detect that there's a little bit of grease film on the surface. We're going to lubricate the sliding surface here and this surface here, the two shiny surfaces, the one that's tapered and then the one that's cylindrical. Once it's lubricated, then we're ready to go back in the mill. So we're going to put it in here and we're going to just free thread it, and you can feel it get started. That's all you want. You're going to get it started, and then we're going to come in with this tool. This tool is pretty sweet because it's got a torque limiter on it. You're going to use your black one, and we're going to come up here and just drive it home till it clicks. And so it's stopped, and that's the click. That's the torque limiter. That thing is installed and good to go. Now, let's say that you do not have this tool and you have to use this one. So, as mentioned before, you have to have something in the middle of this. You can't just put this on the spindle because you'll ruin your collet that's way too expensive for what it is. You don't want to ruin it. Let's just be nice to it. So always put something in the middle. So when we're putting torque on this, here I'm actually going to loosen it just a little bit first. So I've got my support pin in the middle, and I'm going to come onto the collet, and as I'm tightening it, you can see how fiddly this is. Like I'm struggling with it because I need two hands. There we go. All right, so I'm going to come around, and I can feel that it's stopped now. So now the question is, how tight do I make this? I don't have a torque limiter on this tool. And so the way that we know it's tight enough is that we're going to move it until this part of the spindle spins. And you might not be able to detect that it's moving, but do you see I'm just spinning the bottom shaft of the spindle. It's all together. And what's happening here is that we're overcoming the holding pressure of the drive belt. So here, I'll take you up here. If you can sight in just right in there and take a look at the belt on top of the spindle, when I turn this thing, we're slipping the belt. And so the holding pressure of the belt is just the appropriate amount so that we get the collet at the right torque. And so that's how we know. We're just going to go and move it until it stops and it's moving that shaft, just like that. Don't try to counter hold this thing and make it tighter. If you've tightened this too much, or if you've never actually serviced the collet, the collet may be stuck. You may not be able to retrieve it out of the spindle. Do not apply pliers or channel locks or any sort of tool like that to the spindle. You will ruin the spindle. If you have a stuck collet and the spindle still has life in it, you can send us the spindle and we can extract that collet in a controlled environment and send it back to you. Okay, so we're in. Everything's beautiful, it's clean, it's torqued, it's ready. Now we're going to come back to vPanel and complete the job. So we're just going to tell it OK. We're going to close our door so that it knows that it's safe to move. And then we're going to tell it go close collet. And that'll send the mill back to its home position, and it'll be ready to do your next maintenance item or continue milling. All right, so as far as the machine's done, you've now completed your collet maintenance. And again, this is Dention's methodology. It's not outlined in the book for the machine. This is just what we have found works the best in actual production on Roland equipment. So if you do end up finding that you need some stuff, we've got our a web store. You can order collets, you can order spindles, anything you need. We can help you out. Links in the description down below. If you like this kind of thing, we're consistently putting up more and more content, and we're getting deeper. We're going to go into more and more interesting things when it comes to these workhorse machines here. So definitely make sure you're liking and following all that fun stuff. We'll see you around on the next one.